Everybody, welcome to this afternoon's late afternoon session. I'm Scott Miller from NextFlex. It's my pleasure to be your session chair today. And I would like to introduce Madison Maxey from Loomia, who will be giving us our first talk.
All right. Hi, everyone. Thanks so much for being here today. This whole session is a little bit more about e-textiles, different kinds of flexible electronics. Just out of curiosity, who here is in the e-textiles world? Okay, great. We have a good representation. Perfect. And so, my goal with this presentation is to just kind of share some of the development that we've been doing inside of our company, Loomia. We focus on e-textiles, and there's always these challenges around integration. So I'm sharing a case study about some challenges and failures we had with substrates we were using and how we resolved them, kind of just to show how engineering and development can happen in this space. I'll also provide some general information about the field for people who aren't in it, and kind of invite you into why this is an interesting space. Okay, so let's start with some background. There are lots of different types of e-textiles. They can be knit, woven. We'll hear from some people later today who are doing threads and different kinds of techniques. The kind that we do are laminated, and that has a really close tie with printed electronics because you can print electronics on TPU, put it on a textile, suddenly you have an e-textile. Woven and knit sometimes are a little different structurally. So most of my information is related to this laminated style. And whenever you're making an e-textile, there are kind of 7 layers of the stack. There are different techniques to solve just about any problem. For us, we spent a lot of our time working on the first 5. So getting down from like, what do we use for the conductor and printed electronics? It's generally ink. We use a mesh, all the way up through insulation. Okay, how do we protect this electrically and from the environment? We didn't spend as much time thinking about integration. We're like, we can laminate this to a fabric and then it's done. But what we're learning over time is that the fabric you laminated to actually makes a pretty big difference. And I'll share that as we get into the case study. So this is the motivation. We were doing testing on some of our circuits. This is an X-ray of a heater that we developed. We were doing some bench testing with Binghamton University, and we found that our samples were failing in this kind of explosive way. You can see there's like a big burnout for these parts. And this is something that we had never seen before. We also hadn't tried laminating to this particular substrate before, which you can see over on the left-hand side. So we were trying to figure out why this is happening and how do we learn from this in order to inform our integration in the future. All right, and so we'll get to the answer to this, but I'll also tell you a little bit more about our technology because I think that will give you more context as we kind of problem solve for this case study. So this is our product. It's called the Loomia Electronic Layer. It's a soft and flexible circuit. You can kind of imagine that X-ray you saw is one of these traces here. And we can pattern it to do all sorts of things. And generally, we laminate it onto some kind of leather, knit material, sometimes even wood veneers, all sorts of different materials. And this is just a video that tells you a bit more about our technology.
The Loomia Electronic Layer is a first-of-its-kind smart fabric. The LEL is sewable, bondable, washable, and is made of soft, flexible circuitry, making it a seamless fit into any product. The Loomia Electronic Layer can be programmed for a variety of functions, from touch sensing to temperature sensing and heating, to light sensitivity with paper-thin lighting elements. Multi-purpose, flexible, smart.
Right, so obviously this is a marketing video. It's there are many different kinds of e-textiles. This is sort of just the very glamorous overview, but getting a little bit more into the weeds, kind of where we like to try and sit is a good combination of mechanical and electrical performance. I think that especially now with a lot of new printed inks on TPUs, they're also moving into this electrical and mechanical performance category, especially with things like liquid wire. But we focus on materials that are very robust mechanically, for example, won't change resistance too much when stretched and things like that, but are generally fairly low resistance. So it's our goal to move up into this right quadrant as much as we can. And as mentioned, the whole topic of this talk is about integration into different kinds of substrates. So our material gets laminated either using a pressure-sensitive adhesive or a heat-activated adhesive into different kinds of trims. This example that I started showing you where we saw some failures, we're using a heat-activated adhesive to bond to a base material. And within that, we started